Next, we have to discuss about time, speed and distance. There are three formulas mainly. First formula is that distance, that is equal to speed into time. Speed is equal to distance by time. Time is equal to distance by speed. Next, we have to discuss about some tips. To convert kilometer per hour to meter per second, we have to do x into kilometer per hour. That is x into 5 by 18 meter per second. Then, to convert meter per second to kilometer per hour, we have to do y into meter per second. That is y into 18 by 5 kilometer per hour. This is reverse of first one. Okay. If the ratios of the speeds of A and B is A is to B, then the ratio of the times taken to cover the same distance is 1 by A is to 1 by B, or B is to A. There is an example. A boy walks at a speed of 4 km per hour. How much time does he take to walk a distance of 20 km? So we know equation time is equal to distance by speed. So that is equal to 20 by 4. That is equal to 5 hours. Another example is that a cyclist covers a distance of 50 miles in 2 hours. Calculate his speed. So equation speed is equal to distance by time. So that is equal to 15 by 2. So that is 7.5 miles per hour. Another example is that a car takes 4 hours to cover a distance. If it travels at a speed of 14 miles per hour, what should be its speed to cover the same distance in 1.5 hours? So here, distance covered, that is equal to 4 into 14, that is 160 miles. Then speed required to cover the same distance in 1.5 hours, that is equal to 160 divided by 1.5. So that is 106.66 miles per hour. Our next topic is that finding out the average speed when equal distances are covered at different speeds. A lot of us make mistakes in calculation of average speed when the same distance is covered at different speeds. We simply take the average of the given speeds, however that gives absolutely wrong answer. So now get ready to find out what will give you the correct solution. Our first theorem says that if a certain distance is covered at x km per hour and the same distance is covered at y km per hour, then average speed is equal to 2xy divided by x plus y km per hour. This is basically harmonic mean of the two speeds, that is 2 divided by 1 divided by x plus 1 divided by y. So next we have to discuss an example. If a car travels at 40 km per hour on a trip and at 60 km per hour on return trip, what is its average speed for the entire trip? So first thing we should be careful is we shouldn't just average the two speeds. So overall average speed is not s1 plus s2 divided by 2. From the above direct formula, the answer will be 2 into 14 into 16 divided by 14 plus 16. So that is equal to 48 km per hour. If we have to find the average of more than two speeds, average speed will be the harmonic mean of all such speeds. So n divided by 1 by a plus 1 by b plus 1 by c plus 1 by d. Here n is equal to 4. That is the number of variables. Our next example is that if a person walks at 4 miles per hour, he covers a certain distance. If he walks at 9 miles per hour, he covers 7.5 miles more. How much distance did he actually cover? Now we can see that the direct application of our usual formula, distance is equal to speed into time, or its variations cannot be done in this case and we need to put in extra effort to calculate the given parameters. So let us see how this question can be solved. So for these kinds of questions, a table like this might make it easier to solve. So here distance as d, speed as 4 and time as 3. So distance is d plus 7.5, speed as 9 and time as 3. let the distance covered by that person be d. Walking at 4 miles per hour and covering a distance d is done in a time of d by 4. If he walks at 9 miles per hour, he covers 7.5 miles more than the actual distance d, which is d plus 7.5. He does this in a time of d plus 7.5 divided by 9. Since the time is same in both the cases, that is d by 4 is equal to d plus 7.5 divided by 9. That is 9d is equal to 4 into d plus 7.5. So that is equal to 9d, that is equal to 4d plus 13. So d is equal to 6. So he covered a distance of 6 miles in 1.5 hours. Our next topic is that finding out the distance when equal distance is covered at different speeds and the total journey time is given. So first theorem says that a person goes to a destination at a speed of s1 km per hour and returns to his place at a speed of s2 km per hour. If it takes t hours, then one-way distance, that is equal to total time taken into product of two speeds divided by addition of two speeds. So that is equal to t into s1 into s2 divided by s1 plus s2. Another example is that a boy goes to school at a speed of 3 km per hour and returns to village at 2 km per hour. If it takes 5 hours, what is the distance between the school and the village? So here, distance between school and village is 5 into 3 into 2 divided by 3 plus 2. That is 6 km. Our next topic is that finding speed or time required after crossing each other. Here theorem says that if two persons or trains A and B start their journey at the same time from 2 points P and Q towards each other, and after crossing each other they take A and B hours in reaching Q and P respectively, then A speed divided by B speed, that is equal to root B divided by root A. Using this relationship you can find out the missing variables, which can be either speed or time. Once these are known, you can easily find the distance. For examples, if two trains, one from Howrah to Patna and others from Patna to Howrah, start simultaneously. After they meet, the trains reach their destinations after 9 hours and 16 hours respectively. The ratio of their speed is, here while we move on to our answer using the above relationship, the ratio of their speed is root 16 into root 90. So that is equal to 4 by 3. So that is 4 is to 3. Equal to 120 divided by 100 into 5000. That implies x is equal to 35. Hence, if he makes a profit of 35% on the second, it comes to a total of 20% profit on the whole.